Okay, as you can see on the board, indicial, or we call it exponential equation. What do we mean by indicial or exponential equation? Any equation in the form 2x 2 raised to power x equals 16 for instance, or you can have 3 raised to power y equal 81 etc. are called indicial or exponential equation. First, what do we mean by equation? As we all know, equation is any expression in this form with an equality sign. Is a mathematical sentence or statement that with the sign equal to. And in any equation, there must be a letter we are solving for. So for instance, in this, the unknown is x. Here, the unknown is y. So any equation, there must be a letter that we are solving for, and have this at the back of your mind that both sides of an equation must be equal. So without solving, x is 4 because 2 raised to power 4 will give us 16. Similarly, in this place too, y is 4 because 3 raised to power 4 will give us 81. So these are very good examples of exponential equation. In mathematics, we have laws. These laws, these formulas are what we must apply to solve problems. Just like what I did in indices, I gave us 10 laws. So here we have just 3 laws. Laws of indicial equation. The formulas or the laws we use. Laws of indicial equation. Law 1. The law states that if the bases are equal, okay, if the bases are equal, then the powers must be equal. Meaning, if we have 2 raised to power x equal 2 raised to power 5, you can see clearly the bases are equal. The base here is 2, the base here is also 2. X must be equal to 5. If the bases are equal, the powers must what? Be equal. So that here and the right hand side will give us the same answer. 2 raised to power 5 is 32. 2 raised to power 5 is 32. 32 is equal, is the same as the 32 we have here. Law number 2. If the powers are equal, okay, if the powers are equal, then the bases must be equal. Is that okay? So for instance, okay, let's say we have 2 raised to power x or 2 raised to power 3, equal y raised to power 3. Because we said if the powers are equal. Look at this, the power here is 3, the power here is also 3. The base must be equal. It means letter y must be what? 2. Then the third one is what we call law of reciprocal. That law of reciprocal, okay? The law is used in a situation whereby we have, let's take for instance, we have something like this. We have this, okay? We have a question like this. How do we make use of this law? We are solving for x because x is the unknown variable. So what do we do here? We are going to use the reciprocal of this or the inverse of this to multiply both powers. So how do you solve this? You write x raised to power 3 over 2 equal, we know that 27 is the same as what? 3 raised to power 3. You now apply the law of reciprocal. The reciprocal of 3 over 2 is what? 2 over 3. So you use that to multiply both powers, that is 3 over 2 times 2 over 3. Once again, this is the reciprocal of this, equal 3 raised to power 3 times 2 over 3. Now, if we cut out here, 3 divided by 3 is 1, 3 divided by 3 is 1, 2 here 1, 2 here 1. You discover that the left hand side is what? X raised to power 1, which is x. Coming to the right hand side, we can make this over 1 so that we have numerator, denominator, and if the sign is multiplication, we cut. We use the up to cancel it down. 3 here 1, 3 here 1. What do we have left here? 3 raised to power 2. At the end of the day, x is equal to 9. We can check whether we are right. If you pick this 9 and put in place of x, we are having what? 9 raised to power 3 over 2. If you simplify this, we are going to get what? 27. Remember the law that states that a raised to power m over n is equal to what? Root the base. I'm taking us back to indices. Indices itself, indicial equation, we are still discussing indices. So the base under the root, the denominator here, into bracket the numerator. So if we apply that here, we are going to have what? Root the base 9. Remember, if the denominator is 2, you don't need to write it. Then into bracket raised to power the numerator, which is 3. Now, what is the square root of 9? 3 raised to power 3. And the answer is what? 27, which is this. So this side is equal to this side if x is what? 9. So the answer is 9. So this is how we use the law of reciprocal. So this side is equal to this side if x is what? 9. So the answer is 9. So this is how we use the law of reciprocal. So at this point, I have introduced the topic. You know very well that after the introduction like this, I will start solving problems. So stay tuned. As you can see on the board, we have questions. We have to solve the following equations. When you look through the questions from A down to F, you discover that there is a letter. We call them unknown. That is what we have to solve for. Okay? And when you solve an equation means find the value of the unknown. Okay, let's have our solution. In question A, we have 3x raised to power 3 equal 24. First, what are the things disturbing the letter x from standing alone? We have this 3, the coefficient, and we have this 3, the index or the power. So, the sign connecting this 3, remember, when a constant multiplies this, that means the sign is multiplication. So, opposite of multiplication is division. So, we are going to say divide both sides by 3. So that gives us 3x raised to power 3 all over 3 equal 24 all over 3. 3 cancel out 3. So here we have what left? X raised to power 3 equal 8. We can write this 8 in index form. That will give us x raised to power 3 equal 2 raised to power 3. Now, law 2. If the powers are equal, the bases are equal. So by comparison now, okay, since the powers are equal, it means x is equal to 2. That is the answer. You can check whether you are right or wrong. How? When you pick these two and substitute it here, it becomes what? 3 times 2 raised to power 3. 2 raised to power 3 is 8, and when you multiply by 3, that will give us 24. Okay. B, we have x raised to power minus 2 over 3 equal 9. Here we are going to apply law number 3, the law of reciprocal. How do we do that? First, we are going to write this 9 in index form, and that gives us x raised to power minus 2 over 3 equal raised to power minus 2 over 3 equal what? 3 raised to power 2. The power of x is minus 2 over 3. We want x to stand alone, so it's the reciprocal of this that we are going to use, not this. Is that taken? So the reciprocal of minus 2 over 3 is what? Minus 3 over 2. So multiply both powers by the reciprocal. Okay, that is what we are going to do. By the reciprocal of minus 2 over 3. And the reciprocal is what? That is, we are going to multiply both sides by what? Minus 3 over 2. This is the reciprocal of this. If there is no minus, you remove the minus here also. So that gives us x raised to power minus 2 over 3 times minus 3 over 2 equal 3 raised to power 2 times minus 3 over 2. Multiply both powers. So you discover that here 2 here 1, 2 in here 1, 3 here 1, 3 here 1 also. Minus 1 divided by 1 is minus 1. Minus 1 divided by 1 is minus 1. And minus 1 multiply minus 1 will give us plus 1. X raised to power 1 is the same as us writing x equal 2 here 1, 2 here 1. You discover that the right hand side we are having what? 3 raised to power minus 3. We are going to remove the minus sign, and that will give us x raised to power 1 all over 3 raised to power 3, which will give us what? 1 over 27. We can check whether we are right or wrong. If you replace x with minus, if you replace x with 1 over 27, the left hand side is now what? 1 all over 27 raised to power what? Minus 2 over 3. Remember the law 10, if the power is negative, you just turn it upside down, it becomes what? 27 over 1, which is what? 27 raised to power 2 over 3. There is no more minus. If we simplify this, it's the same as root 27, the 3 here, all raised to power 2. Now, what is the cube root of 27? Is 3 raised to power 2. That gives us what? 9, which is this. So if x is 1 over 27, we discover that the left hand side is what? Is 9. Both sides of an equation must always be the same. That is the meaning of the symbol equal to. Now in C, we have 5x equal 80 x raised to power minus 1 over 3. The first thing is to divide both sides by 5. 5 as a coefficient is less than 80. So we divide both sides by 5. That will give us 5x all over 5 equal 80 x raised to power minus 1 over 3 all over 5. 5 will cancel out 5. We therefore have x equal 80 divided by 5 is 16. X raised to power minus 1 over 3. We need to bring this x to the left hand side. The sign in between them is multiplication, and opposite of multiplication is what? Division. So again, we need to do what? Divide both sides by x raised to power minus 1 over 3. So that gives us x all over x raised to power minus 1 over 3 equal 16x raised to power minus 1 over 3 all over x raised to power minus 1 over 3. This cancel out this. So we're having only 16 on the right hand side. Now this side, as the base is x, the base here is x, because we can write this as x raised to power 1. Okay, the power of this is 1. X raised to power 1 is still the same as x. Now we are going to apply law 2 because this is division rule. Since the base are equal, we are going to pick 1. And since the sign is division, we are going to subtract the power. So that gives us 1 minus. The power of x here is also having a minus, so we are going to write minus 1 over 3. We are going to bracket the signs, okay, equal what? 16. Minus times minus will give us a plus, so that is what? X raised to power 1 plus 1 over 3 equal, the 16 can be written as 2 raised to power 4 in index form, okay? Now, 1 plus 1/3 is that taken? It's going to give us one whole number, 1 over 3. And when you change one whole number, 1 over 3, to what we call improper fraction, we are going to have 4 over 3. So when you solve this, x is going to give us 4 over 3 equal what? 2 raised to power 4. Now we are going to multiply both powers, okay? Multiply both powers by the reciprocal of what? 4 over 3. And the reciprocal is what? 3 over 4. That's good. I can see you are flowing. So that gives us what? X raised to power 4 over 3 times 3 over 4, okay, equal 2 raised to power 4 times 3 over 4. The 4 here, we cancel the 4 here. 4 here 1, 4 here 1, 3 here 1, 3 here 1. So this side is just x. And what do we have left here? 2 raised to power 3, and that gives us 8. Okay, the answer there is 8. Again, we can check whether we are right. All we just need to do is to put 8 where we have x. Let me do that quickly. If you put 8 here, it's not going to become 58 because 5x implies what? 5 multiplied x multiplied by x. So 5 multiplied by 8 is going to give us 40. So the left hand side is 40. If we put 8 here, the right hand side become what now? 80 times 8 raised to power minus 1 over 3. That gives us 80 times, if we remove the minus sign, we are going to have 1 all over 8 raised to power 1 over 3. And that gives us 80 times 1 all over cube root of 8. We are going to have 80 times 1 over 2, because 2 is the cube root of 8. So 2 here 1, 2 here 40. So you discover that the right hand side is also a what? Is also 40. Okay, we are moving, we are making progress. Now to question D, we have 4 raised to power bracket open y minus half, okay, equal what? 2 raised to power y raised to power 2. First, since the base here is 2, we are going to write this 4 in index form, and that is going to give us what? 2 raised to power 2 is 4 into bracket y minus 1 over 2 equal what? 2 raised to power y squared. By comparison, since the base are equal, by comparison, okay, by comparison, since the base are equal, it means the powers must be equal, so we equate the powers. So that gives us what? 2 bracket y minus half equal y squared. We open the bracket, that gives us 2y. 2 times 1 over 2, the 2 is going to cancel this. So we have what? Minus 1 equal what? Y squared. This has, in fact, what we have here is I love mathematics. Is now what we call quadratic equation. Because quadratic equation is said to be a polynomial of highest degree 2, you can see clearly that the power of this n of this y is 2. So quadratic equation, you see, we have a lot to discuss. Okay, quadratic equation, whether I like it or not, is still a topic I'm going to trash. So in fact, secondary school student, you are so lucky to have me. I mean, maths doctor is here to solve your problem in mathematics. Before you know what is going on, how you just wow. So maths is interesting. Maths is sweet, interesting, in fact, very easy. So let's go there. Let's have this. Let's continue with our work. Don't mind me. I'm so excited right now because I'm solving mathematics. I'm just so happy. So quadratic equation, the highest power is going to come first, which is 2. So what we are going to do here, if we bring this to this side, bring this to this side, we are going to have nothing here. Okay, we are going to have 0. Okay, so that gives us y squared. By the time this 2y cross, is going to become minus 2y, and by the time this minus 1 cross to this side, is going to be plus 1. We can rearrange this and write what now? Y squared minus 2y plus 1 equals 0. Rearrange simply means, all these come to this side, while these come to this side. Rearranging is different from collecting like terms. When you are collecting like terms, is that taking the sign will change when crossing the equality sign, but if you are rearranging the signs are going to remain the same. So to rearrange now, if you watch, you discover that the minus plus remain minus plus. What I did, I rearrange. I did not collect like terms. Now, how do we solve quadratic equation? We'll use what we have here, including the signs. We have 4 methods for solving quadratic equation. You will use it to multiply what you have here, okay, what you have at the beginning, to get what we call the product. To get the product, which in this case, our product is going to be y squared multiplied by plus 1 will give us plus y squared. Then we need to get what we call the sum. The sum is what you have left in the middle, including the sign, so that gives us minus 2y. Now, after obtaining the product and the sum, we are going to think of two numbers, okay, that two factors that if you multiply, okay, will give us plus 1. Remember, the coefficient here is plus 1. It's going to give us plus 1y squared, and when you add, we give us minus 2y. Without wasting time, they are what? Minus y and minus y. If you multiply minus y by minus y, it's going to give you plus y squared, okay? And if you add minus y plus minus y, plus times minus is minus, so minus y is going to give us minus 2y. What do? It's just like having minus 1, minus 1. Minus 1 is going to give us what? Minus 2. Because the law of basic operation states that if you are simplifying and the signs are the same, okay, the signs are the same, okay, just reason minus 1, you discover that the signs are the same. So if the signs are the same, all you do is ignore the signs, add the two numbers together and bring back the sign. So minus 1. When you ignore the signs, you do 1 plus 1, the answer is 2. You attach a minus back, the answer is minus 2. So minus y is minus 2y. Now this and this is going to come into the equation to replace this middle term, okay, the sum. So that implies y squared remain the same, then the minus y, then this will also remain the same, which is the plus 1 equal 0. The minus y here is still the same as the minus 2y. That is quadratic. The method I used here is what we call the factorization method. As I said earlier, we have 4 methods for solving quadratic equation. I'm still going to get there. We are going, in fact, we have a lot to discuss. Now, we need to factorize. What is common? This and this. Y is common. So bracket open, we are going to have y minus 1. Because if you expand the bracket, it's still going to give this. Now the sign here is a minus. You write it down. What is common? What is the highest common factor between this and this is 1. Okay, y divided by 1 will give us 1 y plus 1 divided by minus 1 is to give us what? Minus 1. Note, what we are going to have in the two brackets must be the same. So that gives us what now? You now look at this and this. Again, what is common is what? Y minus 1. You factor it out, you open another bracket. When you divide all this by this, you are going to have this left. Why? Because this is going to cancel out this. Now, the sign here is a minus. If you divide all this by y minus 1, y minus 1 is going to cancel out y minus 1. We are going to have 1. Bracket close, all equal 0. Now, in mathematics, if A multiply B and the answer is 0, it means what? Is either A is 0 because 0 times B is 0, or A is not 0, B is 0 because A multiplies 0 is still going to be 0. So at this point, we just need to apply that concept that since bracket means multiplication and this multiply this gives 0, it means this y minus 1 equals 0, or y minus 1 this equals 0. And since they are the same, we just collect like terms now. If minus 1 is coming to this side, we add 1 to both sides, y equal 1. Yeah, also y equal 1. So we can write twice. Okay, that is what we are going to get here is still the same as this into two places. Now we can check whether we are right. If you pick 1 and put here, okay, put 1 here, 1 minus half is going to give us half, and 4 raised to power half. When you apply the law, you use the same as square root of 4. So the left hand side is 2. That is mass. When you look at the right hand side, if you substitute 1 in place of y, we are going to have what? 1 raised to power 2, 1. And 2 raised to power 1, 2. Both sides are equal. So I believe I have space for we are now going to letter E. Question E. Okay, E, we have what? 9 raised to power 1 plus x equal, multiply, not equal, multiply by 3, okay, equal 27 raised to power minus x. Since the lowest base here is 3, we are going to write all this in base 3 in index form. So that gives us 3 raised to power 2 bracket 1 plus x, because 3 raised to power 2 gives 9. Multiplied by the power of this 3 is 1. Writing 27 in index form, we are going to have 3 raised to power 3 bracket minus x. Now note the way I'm using my brackets here. Since the term here are 2, it is the power that I put in bracket. But since the term here is 1, we just have minus x, it is this that I put in bracket. Yes. So if we open the bracket here, we are going to have 3 raised to power 2. 2 times 1 is 2 plus 2x multiplied by 3 raised to power 1 equal 3 raised to power 3 minus. No. You see, I'm so excited. 3 times minus x. We are going to multiply the powers. There's a law in indices that states that when the power inside the bracket, you have 2 powers, one inside the bracket and the other one outside the bracket. The 2 powers will multiply. So 3 multiply minus x will give us minus 3x. Okay. Now we are going to apply the product rule or one of indices to the left hand side, because before you apply your comparison, you must have a single base on the left hand side and a single base on the right hand side. So since the bases are equal, we are going to pick just 3. Okay, we are going to add because the sign is multiplication. So that gives us 2 plus 2x plus 1 equal 3 raised to power minus 3x. If we simplify this, we cannot add this and this together because they are not like terms. But some students, they will tell you 2 plus 2x is 4x. You have failed it. All your efforts go down the drain. So there are some things you just need to have at the back of your mind 2 plus 2x is just like saying 2 plus 2 oranges, and you are saying it's 4 oranges. No, it's wrong. It will only be 4 oranges. As to me, it is what? 2 orange plus what? 2 orange. That will give you 4 orange. Is that taken? So you can't add this and this together, but rather you can add this and this because they are both like terms. Is that taken? They are both constant. They don't have x. So that gives us 3 raised to power 2 plus 1 is 3 plus 2x equal 3 raised to power minus 3x. So when you look at the base are equal. Okay, the base are equal by comparison. Okay, by comparison, since the base are equal, we can now equate the powers. I'm using what? I'm using law number 2 or thereabout, yes, because the law 1 states that if the powers are equal, no, it is law 1, yes, it's law 1. If the base are equal, the powers must be equal. So we have what now? 3 plus 2x equal minus 3x. Is that taken? If you group like term, you subtract 2x from both sides. The 2x minus 2x here will give 0. So you come to this side and you'll be having what? 3 equal what? Minus 3x minus 2x. So that gives us what? That gives us 3 equal minus 3x minus 2x. Remember, if the signs are the same, you ignore the signs, you add them together and put back the sign. So here we are going to have what? Minus 5x. We are solving for x. What is disturbing our x? Is minus 5. We divide both sides. Okay, divide both sides by what? By minus 5. So that gives us what? 3 all over minus 5 equal minus 5x all over minus 5. Minus 5 cancel minus 5. So minus 3 over 5 equal to x. We can leave our answer in this way, or you rearrange it, or x equal what? Minus 3 over 5. If minus 3 over 5 is x, it's still the same as saying what? As saying x is the same as minus 3 over 5. So we can check. Let me quickly do the checking. Okay, if I put minus 3 over 5 here, plus times minus, we give me minus, and when you solve, 9 raised to power 1 plus 3 over 5. Okay, multiply by 3, that is the left hand side. 1 plus 3 over 5 will give you one whole number. 3 over 5, we change it to improper fraction. 1 times 5 is 5 plus 3, 8. So we're having what now? 9 raised to power 8 over 5 multiplied by 3. Changing this to index form will give us 3 raised to power 2 times 8 over 5, or bracket 8 over 5 multiplied by 3 raised to power 1. If you multiply this, it's going to give us 3 raised to power 16 all over 5 times 3 raised to power 1. The product rule, since the base are equal, we are going to add the powers. That is 3 raised to power 16 all over 5 plus 1. If I make this over 1, the LCM is 5. So I have 3 raised to power LCM is 5. That gives me 16 plus 5 divided by 1 is 5 times 1 is 5. So the answer is 3 raised to power 16 plus 5 is 21 all over 5. This is what we obtain as the result for this. Now if we solve this, if we pick this, we are having what? 27 raised to power minus x, and our x is what? Minus 3 over 5. So if we put minus 3 over 5 here, the minus multiply, we are going to have just 27 raised to power what? 3 over 5. Exactly. Now 27 is the same as 3 raised to power 3. Okay, 3 raised to power 3 is 27. So we have 3 raised to power 3 multiply 3 over 9, 3 over 5, that is 9 over 5. See,